This is question 3. In this question, you're asked to find the volume of a solid generated by rotating the region about the x-axis. Step 1, as always, sketch the region. It doesn't have to be super accurate, it's just for you to get an idea of the region that you're working with. So this is the parabola. The roots of the parabola are -3 and 0. Here's the line y equals 10. We also want to find these intersections. So the intersections are -5 and 2. We're interested in rotating this region about the x-axis. So let's set up our integrals. The first part is between -5 and -3. Recall that the formula to calculate the volume of revolution is pi times the lower bound is pi times the integral from the lower bound a to the upper bound b of the upper curve squared minus of the lower curve squared dx. This is not the same thing as this guy, so be very careful with this. What's our upper bound? The upper curve is 10. The lower curve is the parabola. First part done. Second part, the upper curve is y equals 10. The lower curve is the x-axis, or y equals 0. The third part is the integral from 0 to 2. The upper curve, that's going to be 10. And the lower curve is the parabola. Because of the symmetry of the question, we can see that this part over here has the same area as that part over there. So we can simplify it even further. The second integral, we can actually compute it in our head if we want to. So that would be 300 pi. And you can use your GDC to compute the first integral. So the final answer will be 2956 pi divided by 5. This is the end of question 3. Question 4. This question is on complex numbers, and you're given 2 pieces of information about z. So when we read this question, your instinct, the first question you should ask yourself, should I find a number in polar form, or should I find a number in Cartesian? Looking at the amount of computation we have here, it seems that the Cartesian would be a better move because we can then form two equations and two unknowns. So, first piece of information, we have x minus 1 plus yi times x minus yi plus 2i. We want to expand and simplify this. So first, I'm going to group of the real parts together and of the imaginary parts together. We know this number is purely real. This means that the imaginary part of this number is going to be 0. The imaginary part of this number can be obtained by finding the imaginary part of the product. In other words, x minus 1 times 2 minus y plus xy has to be equal to 0. So y plus 2x minus xy plus xy is equal to 0. Y plus 2x is equal to 0. Second piece of information. We know that this is also true. This means that x minus 1 squared plus y squared is equal to 5. So we have two equations, two unknowns. You can use the GDC, or you can just solve this algebraically. Both options will take roughly the same amount of time anyway. So if I'm doing it algebraically, the value of x would be 2 plus or minus. You can use a GDC to solve the quadratic to save a bit of time. And you will get 1 plus root 21 by 5, or 1 minus root 21 by 5. Thus, the value of y would be negative 2x. So minus 2 root 21 by 5, or minus 2 plus 2 root 21 by 5. And the complex numbers are therefore this guy, or that guy. And this is the end of the question.